Today's lesson will be on the distributive property. There are several number properties, the distributive, associative, and commutative, but we're going to focus on the distributive property today. Number properties are kind of like road signs. They tell you what is okay and what is not okay as you're solving with problems so that you can keep two sides of a problem equal, kind of like number or order of operations. Alright, today students will be able to solve problems using the distributive property, and students will be able to define the distributive property and describe how it can help you to solve a multiplication problem. So let's get started. Here's just kind of a fun slide to help you remember what distributive means. When I distribute something, I break the number apart. Let's say I have a plate of cookies. If I distribute the cookies, that means I break up my group of cookies and hand them out in smaller groups. So I start with a pile of 20 cookies. Since I shouldn't eat that many, I will distribute them or pass them out to my 4 friends. So you can see I give Emily 5, Madeline 5, Lee 5, and Suki 5. Now there are still collectively 20 cookies, but I distributed them, and I'm looking at 20 a different way, as 5 plus 5 plus 5 plus 5, instead of as one group of 20. Alright, I would like you to copy this in your notes. So split your note section up into 3 parts. Label it Numbers Algebra Picture. And here we go. Let's start with a numerical example. So in the distributive property, if I want to solve 3 times 82, for example, that is a little bit difficult to do in my head. So what I'm going to do is I'm going to break up 82 into expanded form like we did earlier this year. So instead of 82, I'm going to call that 80 plus 2. Now these are the exact same value. Please note that 3 outside the parentheses means that we're going to multiply. So instead of 3 times 82, I'm going to do 3 times 80 plus 2. Now, if I take the 3 times the first part, times 80, and I add that to 3 times the ones place, which would be 6, and I add those back together, I'll get the same answer as if I did 3 times 82 on my calculator. So 3 times 80 is 240, plus 6, and I can see that my answer is going to be 246. So that's a numerical example. Let's try a couple algebraic examples. If I have A times B plus C, then what I'm going to do is I'm going to do A times B, and a way that I can write that is just AB next to each other. That is the same as A times B. Then we'll combine that back with A times C, or AC. And then you add that back together. So A times B plus C is equal to AB plus AC. Let's try another algebraic example where we have some numbers and some variables, which is the letters. If I have 3 times A plus 4, then what I'm going to do is I'm going to do 3 times A, which I can write as 3A. This means 3 times A, plus 3 times 4, which is 12. So you're going to get problems later on in your homework today that ask you to simplify. And when they give you a problem like this and ask you to simplify, they want you to multiply the pieces, add them together. Now this is as far as we can go because we don't know the value for A. Alright, let's see what's happening, and if you need to pause to copy that down, feel free to do that. Let's see what happens in a picture. Again, I want to solve 3 times 32. Well, here's a picture of what that would look like. Here's 32. Each rod is 10. So if I had 3 groups of this, then it would be 32 plus 32 plus 32. And I could solve that on my calculator and get 96. Or I could do it another way. I could say, how about we split this into expanded form, 30 plus 2. First I'm going to do 3 times the 30. Okay, you can see that right here. So here's 30. Let's do the 30 times 3, which should be equal to 90. 30 plus 30 is 60, plus 30 is 90. Then we have our 2 ones times 3 is going to be 6. If I add those two values back together, I get 96, which you can see is the same result as if we just did 3 times 32. So let's show it over here. 3 times 30 plus the 3 times the 2, and we end up with 90 plus 6, or 96. So that is the distributive property at work. Please pause and make sure you have that written down. And when you draw these, just do a line. That would be fine. All right, so let's take a look at it another way. You do not need to write this one down. Just go ahead and take a look. Okay, I'm trying to solve 24 times 4. So again, I'm going to write 24 in expanded form as 20 plus 4. So here's what 20 looks like using base 10 blocks. I did 4 groups of those, 20, 40, 60, 80. So that is equal to 80. Then I took my ones place, my 4 ones, and I did 4 groups of 4, which was equal to 16. Because I pulled it apart here, I just added it back together, and I got 96. Let's do that numerically. So again, if I want to do 4 times 24, another way to do that would be 4 times 20 plus 4. 4 times 20 is 80, plus 4 times the ones is 16. Because I pulled it apart, let's add it back together and get 96. Let's try one more of those. Again, you can just watch. 50 times 6. I'm going to write 55 in expanded form, which is 50 plus 5. Here's our 5 groups of 10, or 50. We're going to do 6 groups of that. 50, 100, 150, 200, 250, 300. So that's equal to 300. I had 5 ones, and I have 6 groups of my 5 ones. 6 times 5 is going to be 30. I pulled it apart up here, so I'm going to add it back together, and my total is 330. Let's show that numerically over here. 6 times 55. I'm going to do 6 times 50 plus 5. 6 times the 50 is 300. Plus 6 times my ones is 30. And that equals 330. If you want to go ahead and copy just this part, that would be a good idea. So go ahead and pause and do that. All right, let's look at another example a slightly different way. So we know that the area of a rectangle is length times width. If I take the length times the width, that will tell me how many squares fill up this rectangle. But let's try it another way. Instead of doing 6 times 18, which equals 108, let's go ahead and break up that 18 again into expanded form, 10 plus 8. So we're going to do 6 times 10 plus 8. So what I'm going to do is I'm going to break this apart into 2 rectangles, one that is 10 across and the other that's 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to separate it right here. So this rectangle is 10 by 6. This rectangle is 8 by 6. So we're going to do 6 times the 10. And what that does is it tells me the area of this rectangle right here, 6 times 10. And that, of course, is going to be equal to 60. Then I'm going to find the area of the second rectangle, which is 6 times 8. That will give me this area, which is equal to 48. Now, if I have the area of this rectangle and the area of this rectangle, what would I do with those 2 areas to find the area of the total rectangle? That's right, I would add the 2 areas together. And then once again, I will get 108. So again, that's how the distributive property works. You pull it apart, but you can put it right back together and get the same value. All right, let's look at another example. This is already pulled apart. So here you see 2 times 3 over here. That will give you the area of this rectangle, which is 6. Over here you see 2 times 5. That will give you the area of this rectangle, which is 10. Now, since we have 2 times 3 and 2 times 5, we can actually pull out that 2 and go ahead and do the 3 plus 5 inside, because the 3 plus 5 is equal to 8. So down here you can see if I put those two rectangles together, now my rectangle is one giant rectangle, which is 8 across. So 2 times 8 equals 16. Well, that's going to be the same as if I do 2 times 3 to get the 6 plus 2 times 5 to get the 10. So this would be doing the distributive property kind of the other way and bringing it back to the parentheses here. But again, if I start with this, then I'm going to go ahead and do 2 times 3, which is 6, 2 times 5, which is 10, and add those together to get 16. So it's just another way to look at it. All right, so on your homework, it's going to give you, again, a problem that looks like this. And the directions are going to be to simplify. What they're going to want is, again, because there's an x, you can't actually solve it. You don't know what x equals, but they want you to multiply it out. So you're going to do 5 times the x, which equals 5x. Remember, another way to write 5 times x is 5x. You can see here why, because the times and the x look very similar. Plus, because there's an addition sign here, 5 times the 30. So please copy down this problem where I ask you to show your work. Let's try one more, but a subtraction problem. So if I ask you to simplify 2 times x minus 3, what would that look like? Go ahead and write this problem down. Do it with me. You're going to do 2 times x, or 2x. And then because this is subtraction, you're going to bring that down, minus 2 times 3. So this is your simplified answer, 2x minus 6. All right, here's just one more example. Write this down as well. I want you to write a times b plus c is equal to, again, a times b plus a times c. This would be a strictly algebraic example of what that might look like. And another way, again, to write this would be simply a times b plus c. And another way to write this would be ab plus ac. Remember, when you multiply letters, variables, you can just put them next to each other. So make sure you get that copied down. We have one more example. All right, so when am I going to use this every day? I actually use this in class all the time. So let's see why the distributive property might help us to multiply numbers mentally. If I'm up in the front of the class and I need to do 73 times 6 in my head, that's a little bit difficult. So here's what I do with my thinking. I take 63 times 6, and again, I break up 73 into expanded form. 70 plus 3. So I'm going to do 6 times the tens place, which equals 420. Then 6 times the ones place, 18. Because I pulled it apart, I have to add it back together, and my total is 438. Let's look at how we showed it before. 6 times 73. An easier way to do that would be 6 times 70 plus 3. We'll do 6 times the 70, 420, plus 6 times the 3, 18, and get 438. And if you want to test it out, if you want to try that in your calculator, see if that's what you get, go for it. All right, so that concludes our lesson. There will be another extra video if you'd like to watch that. You're going to do a little IXL practice and then some work on your own in your lesson packet. Good luck.